Hey guys, it's Mist. And I've got another video for you guys. In this video, I'm going to show you two multipliers I made a year ago. Let me show you how they work. So, for this multiplier, it has two 4-bit inputs, and it will output an 8-bit number. The input A is the front here, and the input B is a little awkward, but it's on the side. So there's the first bit, the second bit. This would be the third and fourth bit. So if I wanted to, let's say, multiply 5, which is 1 plus 4 in binary is 5, and 3, which is just 1 and 2. Bruh. To do the multiply, I press this button, and the output comes out here. It's in little endian form, which means this bit right here is the starting bit, and so on. So as you can see, the number we have here is 1 plus 2 plus 4 plus 8, which is 15 in binary. And yeah, you're probably thinking, hold up, multipliers are usually bigger than this. What's going on? Well, I'll tell you in a moment, but let's go ahead and do 15 times 15, the maximum number. So all 4 bits and all 4 bits. Click the button to multiply. And your result should be 225, I believe. So 128 plus 64 is 192 plus 32 is 224, and you add 1, that's 225, so 15 times 15 is 225. I know, right? Let's go ahead and look at the bigger multiplier now. So this multiplier is for multiplying two 8-bit numbers, and the output is a 16-bit output. So, like the last one, the A input's in the front, and then the B input is kind of awkward, but it's the exact same setup. You have 1, 2, 4, 8, and so on. And let's say we wanted to do something like 27 times 15. 1, 2, 4, 8. We will get this result. Oh, and that light, when the calculation's done, the light turns on up there. So let's see, we have 128 plus 16, which is 144, 148, 149, and 256. Yeah, that should be the result. Give me a second. Okay, so 27 times 15 is supposedly 405. So if I take 128 plus 16 plus 4 plus 1 plus 256, we get 405. Let's try 25 times, let's do 25 squared. So we'd get 25. So that'd be 1, 8, and 16. And then we'll compute it. And the result of 25 times 25 is 625. which is 512 plus 64 plus 32 plus 16 plus 1. That is 625. So you're probably wondering, how does it work when the machines are actually kind of small for being a multiplier? And, well, it's quite simple. We're doing the multiplication using serial adders. So what is a serial adder? Well, it's basically just a binary adder that only adds 1-bit numbers. However, you could take the carry out from the first 2 numbers and then loop it back for the next operation. I'll show you how to do that. So if you can, this will be the output, this will be A, B, and then this will be the carry in. Now, let's say we wanted to do like 3 plus 3, right? So we have 3 there, and I guess I'll do this for 3. What would happen is you would first do the 1 plus 1, which would output as 2. So basically, in this situation, the output would be 0, and we'd have the carry in turn to 1. Then what happens is the data 0 here would shift up, and then this guy would shift up. And now we're doing 1 plus 1 plus 1, which yields a 1 on the output. So everything will shift up. There will be a 1 here. This will go away, and the carry-in will be a 1. Now we're doing 0 plus 0 plus 1, which yields a 1. So again, the data shifts up the line. And that'll be our result, which would be 0, 1, or, well, it'd be, there'd be a 0 in the 1's place. There's a 1 in the 2, so that's just 2. And then 2 plus 4 is 6. So this is how you would represent 6 in binary, if that makes sense. And that's essentially how serial addition works. It's just a sequential way to add numbers. Now, from there, to compute the multiply shifts, all you have to do is use a delay in serial for this kind of a shift register design. So I shift the serial bits every 2 ticks into each of these serial adders. And basically, the output from the first 2 serial adders feed back into the input of the middle one, which is our final serial adder. Huh? So if you could imagine, this is essentially what it does. I'm just kind of making it in a parallel model so you could see. Okay. So if you did like 3 times 3, the way the data would be represented is like this. It would be a 3 here, and then on the next column, it would shift over 1. So what we're actually doing with this machine is we're doing the shifts using this repeater delay line on both the top and bottom. So it does the shifts for us, and then all it does from there at the serial adders is add the numbers together. So I'll make the inputs a different color. So we're doing basically 3 plus 6, and if you think about it, 3 plus 6 is 9. Wow! So the output would be 9. Let's go ahead and do another example so this is easier to see. Let's do like 3 times 5. Sure. So you'd have 3 here. Since this input is 0, you would have nothing on this shift. And then up here, you would have a number like this. So 3 shifted over twice gives us 12, because it shift once to 6 and then shift again to 12. Now if you add 12 plus 3, you get 15. And indeed, that is the result of 3 times 5. So that's all this machine does. It just does the shifts in serial and the adds in serial. Basically, the same thing happens with this multiplier, just on a larger scale. Okay. And so with that said, I hope you enjoyed. I will have the schematic. It's a Lightmatic schematic and the world download in the description so that you can use this module in your CPU or computer project. Just make sure to credit. With that said, yeah, hope you enjoyed, and much more to come. I actually have so many projects. I'll show you my schematic list. So, as you can see, I've got plenty of things to showcase. I have like 14 pages of stuff to share with you guys. One of these days I'll go through all of it, but now, with that said, I hope you enjoyed. Expect some more cool stuff to come. Oh, but actually I forgot. So once you get your schematic, just go to load schematics. The name will be, sorry, I've got a lot to look through. This one, Mist's binary multipliers. Load the schematic. Use MR to render it. And here it is. So it has the little one and the big one. So you could just load that in, and then you can use World Edit to move it in wherever you need it moved in.